Welcome back. Today, we're unpacking something huge: how AI is literally rewriting the rules of global industry. We're breaking down the 2026 roadmap on AI for smart manufacturing. Let's just dive right into this explainer.
But first, I want you to imagine a scenario. What if a factory could actually think for itself? Like predict its own mechanical failures weeks in advance, and then heal its supply chain before a human even notices there's a problem. I mean, it sounds completely like sci-fi, right? But as this roadmap shows us, we are standing right on the edge of this becoming everyday reality.
All right, Section 1, the Smart Factory Revolution, from assembly lines to thinking ecosystems.
Tracking the timeline from the source material, you can really see just how fast things are accelerating. Way back in the 1960s, we got flexible manufacturing systems, the early days of automated machines adapting to different products. Then, by the 70s and 80s, computers started running the shop floor. The 90s brought us agile manufacturing to keep up with the whole globalization boom, but think about those bottom two phases. From 2014 to today, we've been deep in the AI and machine learning era. Think deep learning and smart automation. But what's coming up next? From 2025 to 2035, we're entering the next generation AI phase. This is where stuff like agentic AI, that's AI taking independent action, and industrial large language models take over. Guys, we are talking about factories you can literally have a conversation with.
Moving on to Section 2, AI on the assembly line: how intelligence is applied today.
What's super interesting here is this brilliant tree metaphor straight from the roadmap. Think of the base. The deep roots are your artificial intelligence and machine learning. So deep learning, generative AI, federated learning, all that good stuff. Those roots feed all the way up through the trunk to nourish the canopy of the tree. And those branches, those are the actual real-world applications: process optimization, autonomous robotics, supply chain logistics, sustainable manufacturing. The AI itself isn't the final product. It's the invisible root system keeping the entire smart factory alive and growing.
And one of the most vital branches on that tree is the digital twin. It's basically exactly what it sounds like: a highly connected, virtual replica of a physical manufacturing system. Think of it kind of like a massive video game version of a real factory, but it's constantly fed real-time data from actual physical sensors. And why do this? Well, it lets engineers run incredibly complex scenario simulations. You can push a virtual machine to its absolute breaking point just to see when it fails, and you do it all without ever stopping the real assembly line or putting anyone's safety at risk.
And let me tell you, this isn't just some fun digital experiment. It translates to massive, real-world dollars. The roadmap highlights this staggering data point from the automotive sector. By bringing in an autonomous quality management system, one sector saw a 52% reduction in actual production costs. 52%! And that came right alongside a 78% drop in inspection expenses. When AI is applied correctly, the financial and efficiency gains are absolutely undeniable. Which naturally makes you wonder, why isn't this deployed everywhere yet?
Well, that brings us to Section 3, the big AI roadblocks, the messy reality of factories.
This comparison perfectly illustrates the core problem: the massive data divide. On one side, you've got clean lab data. When researchers build an AI, they're usually training it in these pristine conditions with perfectly labeled, standardized data. But then on the other side, you have messy factory data. The real world is just chaotic. I mean, factories often have 30-year-old legacy equipment bolted right next to a brand new robotic arm. The data is locked up in different departments, records are incomplete, and the physical sensors are super noisy. So an AI trained in a perfect lab, it often just completely falls apart when it hits the grease and grime of a real-world factory floor.
The roadmap actually identifies that scaling AI across these industries faces some very specific interlinked hurdles. It's way more complicated than just buying expensive new software. Let's run through the 5 core challenges outlined by researchers and the World Economic Forum.
Okay, rapid fire. Here we go. First, data fragmentation. Basically, crucial info gets trapped in disconnected silos. Second, transformation complexity. Trying to force cutting-edge AI to talk to outdated legacy IT systems is literally a nightmare. Third, governance and transparency. If the AI makes a costly mistake, whose fault is it? Fourth, talent readiness. There's a massive gap in the workforce right now for people who actually understand both heavy manufacturing and data science. And finally, number 5, scaling beyond isolated pilots. So many companies build one really cool AI proof of concept, but then they totally fail to deploy it across their 50 global factories. They just get stuck in what the industry hilariously but sadly calls pilot purgatory.
Now, to actually overcome these hurdles, an absolutely crucial step is solving the black box problem. See, deep neural networks might give you the correct answer, but they don't really tell you how they arrived at it. And in a factory where a single mistake could cost millions of dollars, or worse, injure a worker, you just cannot blindly trust a black box. That is exactly why the roadmap emphasizes explainable AI, or XAI. These are AI systems specifically built to be completely transparent. Human engineers have to be able to audit the AI's logic, understand its choices, and ultimately actually trust its decisions.
Which leads us to Section 4. Next-Gen AI Solutions. Overcoming the hurdles.
One really huge breakthrough here is something called domain adaptation. Remember that challenge of scaling we just talked about? Well, traditionally, if you train an AI on factory A, it completely fails in factory B, because the lighting is off or the machines and sensors are just slightly different. Domain adaptation basically teaches the AI to translate its skills. It learns the core underlying concepts so it can be dropped into a completely new, totally unseen factory environment without having to relearn every single thing from scratch. It's a total game changer.
Then we have this truly fascinating concept, physics-informed machine learning. You see, pure data-driven AI doesn't actually know how the physical world works. It doesn't inherently understand gravity or thermodynamics or structural integrity. But by fusing the hard laws of physics directly into the machine learning models, engineers can make sure the AI never suggests a manufacturing process that is mathematically impossible or physically dangerous. It literally grounds the artificial intelligence in physical reality.
And you can see how these recent advances bridge the gap beautifully. To fight that severe lack of high-quality labeled factory data we mentioned earlier, researchers are using things like GANs, generative adversarial networks, to basically invent synthetic training data. They're also rolling out lightweight AI. This requires way less computing power, meaning you can run directly on the edge devices, right there on the factory floor. So it's making split-second decisions without needing to constantly talk to some massive cloud server halfway across the country.
All right, final section. Section 5, the human-centric future, the vision of Industry 5.0.
Now, you've probably heard of Industry 4.0. That was the whole wave of digitalization and automation. But this roadmap really highlights the shift toward Industry 5.0. Proposed back in 2021, this new vision is all about emphasizing human centricity, sustainability, and resilience. And I want to reassure you, this is absolutely not some dystopian sci-fi pitch about replacing all humans with cold, calculating robots. No way. Industry 5.0 is all about human-machine collaboration. It's about letting AI take over the dull, dirty, and dangerous tasks while actually augmenting human workers so they can focus on complex, creative, and strategic problem-solving.
But to get to that future, legacy factories have to go on a progressive journey. Step 1, you've got to build those foundational connected data infrastructures. You have to smash those data silos. Step 2, develop adaptive, predictive insights using those digital twins and simulations we talked about. And finally, step 3, reach autonomous, self-optimizing operations. But, and this is key, always with human oversight and governance. That is exactly how we built a sustainable manufacturing ecosystem.
If you're planning to share this explainer with your own network, here are a few fun ways to frame this incredible shift. And for those tracking the trends, here are the key tags driving this whole conversation online right now.
Well, that brings us to the end of our deep dive into the 2026 roadmap, but I want to leave you with one final provocative question to chew on. Based on everything we discovered today, do you think AI will eventually replace human factory workers entirely, or will it just make their jobs a whole lot more interesting and way safer? I would absolutely love to hear your thoughts on this, so please let us know down in the comments below. Keep learning, stay curious, and I'll see you in the next explainer.